Let's jump right into this explainer on the absolute highest stakes, multi-trillion-dollar showdown of our time. We're talking about the global race for artificial general intelligence, or AGI. We're way past the point of just watching software companies duke it out for daily active users. What we're witnessing right now is a total, brutal scramble for physical computing clusters, massive sovereign energy grids, and actual mechanical humanoid bodies. It's a fight for absolute geopolitical dominance. When you look at players like OpenAI, Google DeepMind, Meta, xAI, Anthropic, and Microsoft, it's clear the lines between our digital and physical worlds aren't just blurring anymore, they're being completely redrawn.
To really grasp the scale of this, wrap your head around this number: 200,000. That is the staggering amount of NVIDIA H100 GPUs currently powering xAI's Colossus supercomputer, built to train Grok 3 and beyond. 200,000. It's honestly hard to overstate just how massive that is. It represents a complete tectonic shift in how we build AI. We're well past the days of a few brilliant researchers tinkering in a lab to build a frontier model. Today, creating state-of-the-art AI requires the kind of industrial manufacturing and silicon supply chains usually reserved for nation-states. And here's the kicker: all that silicon demands something else entirely.
Investor Kevin O'Leary hit the nail on the head recently when he pointed out a massive incoming collision. Basically, you've got Bitcoin miners with their totally insatiable demand for electricity, and now they are aggressively going head-to-head with the massive demand from AI data centers. They're literally fighting for the exact same power contracts. So the crucial takeaway here is that this isn't just an algorithmic software war anymore. It's a brutal physical battle for sovereign energy grids. Building advanced AI today isn't just about writing better code, it's about physically locking down power purchase agreements, figuring out modular cooling, and frankly trying to secure nuclear or regional grid isolation. In this race, power is the ultimate bottleneck.
Which brings us right to our next front, the enterprise software battlefield.
Okay, so look at how the landscape completely flipped in early 2026. Anthropic actually overtook OpenAI in U.S. enterprise AI spending. They captured 34.4% of the market, just edging past OpenAI's 32.3%. And this shift didn't just happen by accident. It was heavily driven by the massive success of Anthropic's Claude code. That single product generated over $2.5 billion in annualized run-rate revenue, simply by automating incredibly complex agentic coding workflows from massive corporations. What we're witnessing is a fascinating split in the market. On one hand, OpenAI totally dominates the consumer mind share. Everyone uses ChatGPT, and their web traffic reflects that. But on the other hand, Anthropic is quietly locking down the corporate world. They are building these incredibly sticky, high-margin enterprise relationships that are completely anchored in safety, reliability, and their constitutional AI framework. They've managed to secure 8 of the Fortune 10 companies. Why? Because heavily regulated industries will always prioritize absolute compliance over raw consumer capability, every single time. But meanwhile, a total geopolitical earthquake hit the industry when Apple made a huge strategic move. They actually chose Google's Gemini over OpenAI to power Siri across 2 billion devices. For years, the narrative was that Google's AI was seriously lagging behind ChatGPT. But this one deal, worth an estimated $1 billion annually by the way, validated Gemini almost overnight. Apple decided to route its most complex multi-step queries through its private cloud compute directly into Google's Gemini architecture. And if you want to know exactly why Apple made that choice, it boils down to pure multimodal reasoning. By late 2025, Gemini 3 fundamentally dominated GPT 5.1 in the exact areas you need for a next-generation digital assistant. Take abstract visual reasoning, for example. Gemini nearly doubled GPT 5.1's score, but the real shocker is the math testing. Math is a great benchmark for solving unseen, abstract problems. Well, Gemini hit 23.4%, while GPT 5.1 barely even registered at a measly 1%. Apple simply couldn't afford that kind of failure rate on complex reasoning, so they went all in on Google's superior multimodal engine.
Let's shift gears a bit and look at the whole open weights versus closed models debate. It's really turning into a two-sided war. On one side, you have the fortified castles, the proprietary closed models like GPT 5.5 and Claude 4.8. They keep their training weights totally secret and, of course, charge a premium for access. But on the exact opposite side, there's this massive global rebellion of open-weight models. We're talking about Meta's Llama 4 and Chinese models like DeepSeek V4. Now sure, the closed models still maintain a narrow lead when it comes to extreme multi-step reasoning, but these open-source insurgents, they are offering absolutely unmatched cost efficiency, complete data privacy, and global accessibility.
And Meta's open source strategy is literally reshaping the entire commercial software stack right before our eyes. Take Llama Force Scout, for instance. It boasts an unprecedented 10 million token context window. Think about what that means for a business. It means you can process massive, proprietary data sets or even entire historical code bases completely locally. You never have to feed your sensitive information out to an external cloud API again. Because of this, smart enterprises are rapidly building out dual-weight hybrid stacks. They use the cheap, open models for daily, large-scale tasks, and then reserve the expensive, closed models only for the heavy-lifting reasoning tasks. It's brilliant.
All right, let's take this out of the server room and into the physical robotics frontier.
Now, if you spend any time on social media, you might honestly think everyone already has a humanoid robot at home folding their laundry. But when we step back and look at actual commercial deployment readiness, reality paints a very different picture. Elon Musk himself admitted that Tesla's Optimus is still primarily in a learning phase, rather than doing economically productive work. But over at Agility Robotics, their robot Digit is actually leading the pack. It is already out there doing real, revenue-generating commercial work in live, bustling warehouses. And this perfectly illustrates the stark divide between slick CEO hype and actual ground truth. Digit is out there right now, successfully moving over 100,000 plastic totes at a real GXO logistics warehouse. Even more critically, and this is huge, it passed an OSHA-recognized safety field inspection. That is literally the first of its kind for a commercial humanoid robot. At the end of the day, real enterprise procurement relies on proven compliance and actual throughput, not highly edited, flashy demo videos.
But there's a massive elephant in the room here, an inescapable physics problem that all the venture capital in the world just cannot solve: the battery bottleneck. We can marvel at the underlying AI all day long, but physical power is severely limiting real-world deployment. Right now, Digit leads the pack simply because it can survive a full 8-hour warehouse shift. Other incredible pieces of engineering, like Boston Dynamics Atlas, they tap out around 4 hours. And let's be real, you simply cannot replace human labor at scale if your new robotic workforce has to sit plugged into a wall for half the day.
Because of these strict physical constraints, we're starting to see very distinct hardware specializations emerge. For example, Boston Dynamics Atlas is partnering deeply with Google DeepMind to tackle punishing 50-kilogram industrial lifts in extreme temperatures. That's a heavy-duty industrial focus. But contrast that completely with Figure 03. They are explicitly designing for complex, unstructured domestic homes. They're focusing on soft textile environments, delicate tactile sensitivity, and even wireless floor pad charging so the unit can just seamlessly operate in a typical household without getting in the way.
So, how do you actually go about winning this infinite game?
When you look at the timeline, the sheer pace of this capability leap is breathtaking. We are moving so rapidly from those simple conversational chatbots we all played with back in 2022 to the persistent memory models of 2026, like Grok 3 and GPT 5.5. AI is no longer just a tool that answers your prompts. It is actively transitioning into autonomous agentic labor. We're talking about systems that can independently execute complex software plans, continuously, for weeks at a time, with zero human supervision. The march toward advanced metacognition isn't a future prediction anymore. It's already here.
If you're leading an organization into this new, hyper-industrial era, there are 4 non-negotiable imperatives you absolutely have to master to survive 2026. First off, you have to lock down physical energy contracts. Honestly, without secured power, you simply cannot compute. Second, you've got to pivot your business model from traditional SaaS over to pay-per-task agentic labor. Third, balance your data privacy and operational costs by maintaining that dual-weight AI software stack we talked about earlier. And finally, you absolutely must rigorously audit your AI safety using independent third parties. Why? Because as these systems start writing and deploying their own code, autonomous rogue actions become a very real, critical risk for both corporate and national security.
Which brings us to the ultimate, incredibly high-stakes question that every single nation, CEO, and developer has to face in this multi-trillion-dollar race. As AI shifts from being just a digital tool into our actual physical infrastructure, who ultimately controls this? Is it the companies hoarding the silicon, the nations commanding the energy grids, or maybe the global open source community that's releasing raw weights out to the public?
We are no longer just building neat software applications to make our lives a little easier. We are constructing a vast, autonomous cognitive infrastructure that is going to live in our data centers, pulse through our power grids, and literally walk the floors of our warehouses inside physical robots. The choices we make today about safety, access, and control, they are going to permanently rewrite the very definition of human labor. The boundary between machine cognition and human capability hasn't just blurred, it has completely dissolved. So the final thought I want to leave you with today is this. As these systems accelerate relentlessly toward artificial general intelligence, are we truly prepared to be the orchestrators of our own replacements?